sites. So it's not just one site. So sport and health sciences, where I belong and I perform our research, is on St. Luke's campus, which is a slightly smaller campus compared to the main Exeter campus. And that's quite a nice thing, actually, because it's quite a nice community feel to the campus. So typically, this is a picture of St. Luke's, and anybody that you would see walking around St. Luke's will be studying sports science or medicine or perhaps education. So, there's a lot of like-minded people around you. So that's St. Luke's campus. And just, I will be talking a little bit about some of the opportunities to study with us if you're considering postgraduate study. At the time of recording, I appreciate this is going to be on YouTube. So at the time of it being recording, we are top 10 in the world for sports-related subjects, and we're second in the UK for sports science. And we're actually third in the UK for research. So we are a Russell Group institution, which means that we have a real focus on research, which means that Exeter is a great place to be if you want to push your own research forward and further our understanding of a particular topic. So we offer, and all the information is on the website, but we offer a range of postgraduate degrees. We also, that are taught in nature. We also offer PhDs and an MSc by research, which is just purely a research postgraduate pathway, which some of you may be interested in. And our details on available funding for those are updated regularly on our website. So do keep that in mind. So I mentioned that I'm from the Children's Health and Exercise Research Centre, and that I think is somewhat unusual or slightly unique, perhaps in the UK, that we have a dedicated and internationally recognised research-focused paediatric unit, and we're a group of several like-minded researchers, and clearly we let anybody in. So if you're interested in being part of CHIRC, again, do drop us an email. And the work that we do, the research that we do in CHIRC, so the Children's Health and Exercise Research Centre, does fit in quite closely with the Paediatric Exercise and Health MSc that we offer. So that's research-based teaching, and all that research is coming from our department in CHIRC. Okay. So this is the title of the talk and the focus of today's session. And I think it's important in any presentation to discuss what we call a rationale. It's for us in the UK, it's Saturday afternoon. For you guys in Brazil or wherever you are, it's Saturday, it's a weekend. So why is this an important question at all? Why do you need to care about what I'm going to talk about over the next 45 minutes or so? I'm going to try and convince you why this is an important question, because obviously COVID-19 as an infectious disease has, really profound medical and health issues, not related necessarily to cardiovascular disease in youth. So it's not an obvious link there. So I'm going to try and talk about why I think this needs to be part of the conversation, or at least part of our concerns going forward. And I'm going to split it up into sort of very briefly to talk about why we need to care about cardiovascular health, but particularly why do we need to care about cardiovascular health in youth. I'm going to have a particular focus on the vascular component of cardiovascular health. And then we're going to get into the available evidence from the COVID-19 quarantine periods that we've seen around the world. So this may be old ground for many, but just let's not forget for a moment that non-communicable diseases, so diseases that aren't infectious, still remain the highest cause of global death. And of these non-communicable diseases, these NCDs, heart disease, stroke, so these cardiovascular diseases are a significant portion of that global burden of disease. In fact, in the year 2030, 23.6 million people will die from cardiovascular disease every single year. Now, 23.6 million people is just a number. It's just a statistic. It doesn't really mean much to me. I can't picture what 23.6 million people look like. So just to help emphasize that point, in the state of Rio de Janeiro, not the city, but in the state, the entire population is 17 million people. So if you're in the state of Rio de Janeiro now, anybody that you see today, tomorrow, next week, anybody that you see, that only equates to 17 million people. So it still falls short of this 23.6 million people that will die every single year. And I appreciate, the basis of being in Natal. Everybody in this state is just 3 million. So if you add that onto the state of Rio de Janeiro, that still doesn't equate to 23.6 million people dying every single year. Now, it's not all about dying from cardiovascular disease. In fact, when I think about it, I get quite frustrated. I think it's quite lazy. I get quite frustrated by papers that talk about cardiovascular disease mortality, because the reality is, if I could choose to die from a heart attack in my sleep, that seems like quite a good way to go without being flippant about it. That's not a bad way to die. There are actually far more creative and perhaps worse ways that I could choose to die than a heart attack in my sleep. So the point is, it's not just about mortality, it's about early mortality. It's premature mortality. Over 40,000 people in the UK alone this year will die too early because of cardiovascular disease. And the other reason why I really care about cardiovascular disease is because we can prevent almost 4/5 of it. This is a disease that we can actually prevent and do something about. So many of you may be studying at undergraduate or perhaps postgraduate level. You might be the next generation of scientists that can help lower the burden of cardiovascular disease, because it needs to be done. It obviously has huge financial implications as well, which I'm not going to talk about now. So how can we prevent cardiovascular disease deaths? Well, physical inactivity is the 4th leading cause of global mortality. Okay, so this is the global burden of disease. There's a lot of work that would come out in the Lancet, fairly recently. If we look to Brazil, data from Brazil, physical inactivity, so not doing enough activity, accounts for 13% of all deaths. 13%. Okay, and we know that if you could just reduce inactivity, i.e., make people slightly more active, just by 25%, it would prevent 1.3 million early deaths per year worldwide. So this is really something that's quite achievable. This is something that we should strive to do. And again, the financial implications of doing so are quite profound. Okay, so that's cardiovascular health, but why do we need to care about the vascular component of cardiovascular health? Well, this is a slide that Ricardo will know and love, and he'll recognize this immediately. This is data. It's quite a well-cited study. This is data from the Women's Health Survey, where many female nurses were tracked for about 11 to 14 years, I think. And what these researchers did is they split the cohort into two, those who were physically active and those who weren't physically active. And at the end of the study, they looked at the number of deaths from cardiovascular disease in the two groups. And then what this study tried to do is they tried to tease out where the benefit of physical activity is. Okay, so this is on the y-axis here, this is the percentage reduction in cardiovascular events that is explained by these individual risk factors. So in other words, 10% of the benefit of exercise or physical activity is because of favorable changes to body mass index. Maybe let's pick another one. 27% of the benefit of physical activity on your risk of cardiovascular disease is related to favorable changes in blood pressure. So put another way, if I were to take an individual and train them up, so I was to do some exercise training with them, I would look at how I've lowered their risk of cardiovascular disease. I would know that, let's say, if I've lowered their blood pressure, that's quite good, because blood pressure accounts for 27% of the reduction in cardiovascular event. But what you will notice is if you add all of these up, the benefit of exercise on these traditional risk factors only accounts to about 60% of the benefit. In other words, 41% of the benefit of being physically active has nothing to do with these risk factors. So these are risk factors that we all know, and we all learn about when we're going through our university studies, or we know just from the media about blood pressure being bad. But actually, only about half the benefit of physical activity is related to these things. Okay, 41% has nothing to do with any of those things at all. So what explains some of this missing risk factor gap? And this is where you need to have a discussion with Ricardo, because this is something that Ricardo and I both research as part of our PhD. But what we believe to be part of this missing 40% are changes to blood vessel function and autonomic function. So I'm going to talk about blood vessel function. Now, at Exeter, there's lots of different ways of measuring blood vessel function. But one technique that is quite well received is a technique called flow-mediated dilation. So it's an ultrasound technique where you can look at the width of the artery in the arm, so it's the brachial artery. So we can look at the width of the arm, and this is blood flow down here. And what we can do is we can occlude the arm, so with a blood pressure cuff, prevent blood flow to the hand for 5 minutes, let's say. And then you can release the cuff, so you get a hyperemic response, and that acts as a stimulus for vasodilation here. And the wider the arm artery goes, the better, the healthier it is. So this is flow-mediated dilation. It's a test of endothelial function, so the single cell lining on that blood vessel, and it's nitric oxide dependent when performed under certain conditions. And this is shown to be add value to traditional framing and risk factors. Okay, so this test that we use to measure blood vessel function has value in terms of assessing cardiovascular disease risk. And just to point out that this is something that we do a lot of at the university, and we've built it into some of our talk programs here. So we discuss some of the data, our own data, in this research-led teaching. But it's a technique that might be available to you should you want to do further study with us at Exeter. Okay, so that's the vascular component of cardiovascular health. But why do we care about cardiovascular health in youth? Because no child is dying of cardiovascular disease. So why do we need to care about this pediatric component? Well, we now know, in fact, we've known for a while that the process of cardiovascular disease, so atherosclerosis, does start in early life. So this data here is taken from autopsies. Okay, so these are children and young adults and teenagers that have died from a non-natural death. It might be, for example, in a car crash. And under autopsy, researchers have looked at the amount of fat that is covering, let's say, their coronary arteries. And we can see that there's a proportional relationship between the number of cardiovascular disease risk factors these children have and the amount of fat that is covering their coronary arteries. So the take-home message from this is that how you live as a child is directly relates to a build-up of fatty plaques in your coronary arteries. So this is the process of cardiovascular disease. Now, that sounds quite alarming, and it should be. If we didn't know that already, that's something that we really need to tell people about, because people think of cardiovascular disease as a disease that only influences people later life, but that's overt cardiovascular disease. Really, cardiovascular disease has a covert subclinical progression over the lifespan. Now, what's quite exciting about being a pediatric physiologist is that the young people involved in these early studies are now young adults and maybe even middle-aged adults. And so there are a series of longitudinal studies that have tracked their progression over the course of their lifespan. So we now can take a look at just how much does this matter. So there's lots of data on this, but I thought I'd just use a neat example from the cardiovascular risk in young Finns study. So in this study, they measured almost 1,000 teenagers. And they looked at all these different things that are known to be related to cardiovascular disease risk. Okay, so this stands for body mass index. This is overweight or obesity status. And what they did is they kind of gave them like a school report card. They gave them a score for all these different things. Now, they then split the group into 6. If you were really, really top of the class for all of these outcomes, if you're really physically active, if you've got a really good diet, if you don't smoke, if your cholesterol is excellent, if you're in top of the class here, you're in group number 6. If, however, you're obese, you're low active, you have a poor diet, and you smoke, etc., you're in group number 1. Okay, so just remember that for now. Everybody wants to be in group number 6. And what they did is these researchers followed them up 21 years later. And what they did, and this is something that Ricardo did as part of his PhD with us in Chirk, they looked at the thickness of the artery in the neck. This is the carotid intermediate thickness, which sounds like it's slightly a strange thing to care about, but we know this is one of the strongest predictors we have of cardiovascular disease risk. Now, the thicker this is, the less healthy you are. So let's take a look at our kids are now adults. And we have, remember, you wanted to be in group 6 when you were a child. These were the healthy kids. These are the least healthy kids. But this is the thickness of the carotid artery in adulthood. So this is when they were a child, and 21 years later, with the follow-up, this is when they're an adult. And what you can see is there is a difference between if you're in group 6 and group number 1. Now, what does, 0.08 of a millimeter thickening of the artery mean? What does that really mean? Well, actually, that's the equivalent to being about 12 years older in terms of vascular age, which is about 15% of somebody's lifespan. So in other words, this person here, they were measured when they were 13. 21 years later, their artery is this thick. So they're 21 years later. They think that they're 34. This person's 34. This person is also 34. But actually, on the inside, this person is 46 in terms of their year. That's how old they are in terms of vascular age. And you can't see this process in the mirror. Obesity is just one of many risk factors. So that person may not know that they have this atherosclerotic buildup. Okay, so this is why we need to care about it in youth. It does start early, but why vascular health? Well, this is the technique again called flow-mediated dilation that I've already talked about. And flow-mediated dilation, the higher the number, the better on the y-axis. We can see these are all different studies. These are different studies here. Healthy kids have better blood vessel function even than young people who have risk factor status. Okay, so we know that if you are exposed to risk factors in your early life, you might have lower blood vessel function. So this technique, this tool is sensitive to vascular function even early on. Now, this figure is slightly complex, so I'll talk you through it. This is, again, cardiovascular risk in young Finns data. And what these authors have done is they've looked at the number of risk factors a child has, 0, 1, 2 or more, and then they've looked at their flow-mediated dilation, so that ultrasound technique that we just mentioned, okay? And then they've tried to look at how that relates to adult intermediate thickness, the thickening of the artery in the neck. And what you can see is that if you, as a child, have very good blood vessel function, even if you have 2 or more risk factors, you are protected as an adult. Okay, so you want to have enhanced endothelial function. If, however, you have okay blood vessel function, you can see that the more risk factors that you exposed yourself to when you were a child equates to greater amount of risk at the carotid, okay, and greater cardiovascular disease risk. And the same is true for impaired blood vessel function. Now, there is data, and I'm not going to talk about it now, but there's data to suggest that how you live as a child actually influences the thickening of your carotid intermediate thickness independently of your risk factor status as an adult. Okay, so you never get this time back. I think that's important. So ultimately, the number of cardiovascular risk factors in childhood correlates with adult thickening of this artery only in those who have poor blood vessel function. In other words, we need to care about blood vessel function, because if we care about blood vessel function, we can try and maintain this sort of relationship into later life. We want to avoid this atherosclerotic cascade of events. So this is why we care about vascular function in youth. We're trying to prevent fatty streak buildup. We're trying to promote blood vessel function before we get changes to vascular structure. Okay, so now that we've covered that, I just wanted to, for like the next 20 minutes, just to talk about the influence of COVID-19 and the quarantine effect on cardiovascular health in youth. We've covered why we need to care about cardiovascular health. We've covered why it should still be part of a pediatric question, and I've focused a little bit on some of the vascular work as well. So we need to now consider COVID-19 and the quarantine effect, because we are living during a time of pandemic. Now, COVID-19 is obviously an infectious disease that is causing a global struggle, but we need to keep thinking about cardiovascular disease as being part of the conversation and something we need to care about. 60% of all children worldwide live in countries where either a full or partial lockdown is in place. So that's as of April from the World Health Organization. So if you remember, this talk is going to be focusing on physical activity. I'd like to draw your attention to the fact that we're actually living during a time of pandemics, plural. A pandemic has nothing to do with whether or not a disease is an infectious disease or not. So the World Health Organization has labeled physical inactivity also as a pandemic. So if we look here at global activity levels, so this is actually, this is global inactivity levels in young children and adolescents. So 90%, the dark red here means that 90% of young people in these countries are not meeting the recommended guideline amount of physical activity. So worldwide, 80% of sort of young teenagers fail to achieve the physical activity guidelines. That is a pandemic of inactivity. Now, there is a difference between the physical activity guidelines for adults compared to pediatric populations. So children and adolescents are encouraged to achieve 60 minutes of exercise every single day minimum, and that's important that is a minimum. This is data from the European Youth Heart Study. And I just wanted to talk you through this because I think this point is often missed. On our x-axis here, we have quintiles of physical activity. So that's like 20%, groups in different 20%. So this quintile number 5 is the top 20% of the population for being physically active. So these guys are the most active, top 20% for being active. These guys down here are least active, bottom 20% of the class for physical activity. And on our y-axis, this is sort of, it's a log scale, so it's a little bit strange, but this is the risk of having 2 or more cardiovascular disease risk factors. And I've put example cardiovascular disease risk factors up here on the right-hand side of the screen. And what you can see is that if we call these guys 1, if we call this, these are our control group, our comparison group, the most active, as you become less and less active, your risk of having 2 or more cardiovascular disease risk factors increases. So these guys up here are about 3.5, maybe 3.25 times more likely to have several risk factors than our comparative group over here. Now, where this data gets really interesting, because so far that shouldn't be a surprise to anybody. We know that physical activity is beneficial. But where this data gets really interesting is when we look at how much activity these guys are doing in each group. And what you can see, the most active group are doing over 2 hours, so 131 minutes of activity a day. If you do, as a child, 60 minutes of exercise every single day, that puts you somewhere between these 2 groups. So let's say about here, if you do 60 minutes of exercise every single day, you are still more than 2.5 times likely to have to expose yourself to risk factors. Okay, and remember, the more risk factors you have, the more fat there is building up in your coronary arteries. So we really need to think about this. This guideline amount of physical activity is a recommended minimum. Recommended minimum. And remember this slide from early on, physical activity is the fourth leading cause of global mortality. It strikes me that this is going to be a problem, and we need to consider, does lockdown due to COVID-19 reduce physical activity levels further, because we're already not active enough? So there's a limited amount of data on this. It's obviously an evolving situation. So this data is from China, calculated. It was collected between January and March this year. And this is self-report data on physical activity levels and also sedentary time, which I'll share in just a second. But if we look at before the pandemic, this is the amount of minutes of physical activity that this group of so 16, 17-year-olds in China were performing. We can see that compared to before and after the pandemic, we are becoming far less active. When expressed as a percentage, the inactive group, which is defined as people not even doing 30 minutes of exercise a day, increased from 21% to 65%. Those who are doing sufficient physical activity, i.e. getting more than the hour a day that is expressed as the recommended minimum, dropped from 60% down to 18%. So lockdown has dramatically reduced physical activity in these Chinese children and adolescents. What's also interesting with this data is they looked at sedentary time. Sedentary time is something I haven't really talked about too much because I've been conscious of time, but sedentary time is known to be independently and unfavorably related to cardiovascular disease risk. So sedentary time via a different pathway is also independently related to cardiovascular disease risk. And what we can see, if we look at screen time before the pandemic, that's 610 minutes per week. Okay, so that's 10 hours per week. And now we've got up to about, 39 hours per week. Now, a lot of that might be because of schooling. Maybe they're not going to school anymore, so they're doing their school at home, and that involves a computer, and so that's where that screen time is coming from. So what I like about this data is they've broken it up further into screen time activity that's considered to be leisurely activity, and they've also looked at short versus long, so continuous screen time. And we can see that these are worrying trends here in terms of we're now spending more time being inactive for longer. This is data that's come from Italy, and these are really, for something to be a scientific fact, it needs to be shown in more than one place, preferably. So, in Europe now, rather than in Asia, we're seeing similar stories coming from Italy. Okay, so this data has just come out. Screen time in terms of hours per day beforehand, and then during lockdown, we have increased up to almost 7.5, 8 hours of screen time per day. In terms of sports participation in hours per week, we are now reduced from 3.5 down to less than 1.5 hours of sports per week. So we're seeing a reduction in physical activity and an increase in inactivity. Now, this is data from what's called the PANIC study, the Physical Activity and Nutrition in Children study. This is data that's collected in Scandinavia. It's published by the Finnish group. Here we have cardiometabolic risk, and we've got 4 different groups here. EMT stands for electronic media time. So kind of, I guess, sedentary time, screen time. So this group here are doing low amounts of screen time, so not much screen time, and are high physically active. And you can see they're at a low cardiometabolic risk factor, or they're at low risk for having cardiometabolic risk factors. Okay, so this is good news. This group here are low active, but also low sedentary. Low active and low sedentary, which is interesting because these guys are high active, but highly sedentary, and these are less healthy than this group over here. So these are low sedentary and low active, but these group here are high active, but even though they're highly active, because they're highly sedentary, they are at a greater amount of cardiometabolic risk. Now that might be difficult to understand, and it's probably to do with the patterning of physical activity. So I myself am highly sedentary because I work in I do a very sedentary job quite a lot of the time. I'm also very highly active because at the end of the day, I might do an hour on the bike. But that means I'm both high active and high sedentary. And it means that I've exposed myself to continuous hours of sitting down, which we believe to be bad. And of course, no surprise here, The low physically active and the high sedentary time confers the greatest amount of risk. This is really bad news. And this is what I think we're seeing with the COVID scenario. Okay, so certainly for lockdown with me, you know, a lot of Netflix going on, a lot of sedentary time, a lot of screen time, that's not going to be conducive to health. So yes, it seems to be reducing physical activity. It's also increasing sedentary time. Now, there's this weird observation that we have about children and adolescents. They tend to put on weight. Certainly people who are already overweight or obese tend to put on weight during the school holidays. We've seen this in lots of different countries, lots of different groups, lots of different continents have seen this. There's quite a lot of work on this. So we know that when children and adolescents are removed from the school routine, they tend to put on weight. However, during the summer holidays, they are more physically active. So just to explain this figure a little bit, this is during autumn. This is their BMI during autumn, and then this is during the spring. Then this is the summer holiday period, and they come back for the autumn and the spring and then summer holiday. And you can see the trajectory of these curves. The steepness of this line here means they are putting on far more weight over the summer holiday than they are from between the autumn and the spring period. Same goes for here when we go from the kindergarten to the first grade to the second grade. So these are young children. But this is despite an increase in physical activity. So the worry we have is, well, in lockdown, we're reducing physical activity and we're also increasing our energy intake. Typically, children are having maybe one more meal a day, which might be anywhere between 300 to 500 calories extra every single day. So where are these calories coming from? So this is unlikely to be good news. These calories are coming from an increase in crisps, like potato products, red meat, and sugary drinks. So that's interesting because I'm now going to show you adult data about which foods that we typically consume which most drive obesity. So this is adult data now. But remember, the previous slide identified that children in lockdown are eating more crisps, red meat, and sugary drinks. Okay, so here's adult data. These are the foods that are most associated with driving obesity. Crisps, red meat, sugary drinks. So the very things that children are now eating more of are known, at least in adulthood, to drive obesity. So we only have a couple of months of data on this, and no one is becoming obese within a week. So we don't know what this means, but it's unlikely to be good news, and it's cause for concern. Remember, flow-mediated dilation, this blood vessel function technique, the higher the number, the better. Well, we've already seen that young children and adolescents who are obese are characterized by a lower blood vessel function. So again, that's an obesity question. We probably haven't got time or we haven't had sufficient amount of time with our data to see how obesity has increased under lockdown. So my area of interest here is, does the reduction in physical activity and the increase in sedentary time and snacking, these food groups that we're eating, have their own influences? Well, this is data from Liverpool in the United Kingdom, where the researchers showed that there's a seasonal change in blood vessel function. And I talked about that in terms of the summer holidays and compared to the winter with obesity. What these researchers showed that if you increase the amount of vigorous physical activity that you perform as a child, that is the only metric that they measured that predicted or that was related to the increase in blood vessel function, which is a good thing. So only time spent performing vigorous physical activity, not moderate or light physical activity, is actually favorably related to blood vessel function. And also, obesity, even if obesity or adiposity increased over this period, it didn't have a relationship with blood vessel function. So vigorous physical activity is a really important thing to care about, and maybe it's not always necessarily about overweight or obesity. I'm going to show you some experimental data now from Chirk, from our lab, and we can see just acutely blood vessel function here on our y-axis. Remember, the higher the number, the better. This is before and after performing either high-intensity interval exercise or moderate intensity exercise, and they're both performed on a bike. And what's neat about what's attractive about this study design is the exercise bouts were work matched for the amount of energy or work performed during the exercise. What we can see that moderate intensity exercise never actually improved blood vessel function. It's kind of telling the same story as the previous slide. But a single bout of high intensity interval exercise, although blood vessel function went down immediately afterwards, 1 hour and 2 hours later, blood vessel function was improved. Now, we don't know the time course further on. We don't know how long a single bout of exercise lasts, maybe only a couple of hours. But it shows, again, that vigorous physical activity is likely to be important. Remember, children are not performing much sports time. So now let's have a look at screen time here. Remember, so this is data from Italy, and we look back at the data from China. What's interesting with the data from China is they split up their screen time further into leisure time, but also short exposures or longer exposures to screen time, so i.e. more than 2 hours per day. This is data that's come from the University of British Columbia, part of Ali McManus's lab out there. And again, we have our same blood vessel function technique, flow-mediated dilation. And this is before and after sitting down for 3 hours. So these girls who were part of the study just sat down for 3 hours, and blood vessel function was impaired. But what's really interesting about this study, so this is already a worry, because this is what we're seeing perhaps with, we're seeing more sitting time with the coronavirus lockdown. But however, if you interrupt that sitting just with some moderate intensity exercise, you can completely protect yourself from this effect. And by the way, we see very similar data in adults. So if you're considering your own health during lockdown, if you're in Brazil, we know that just getting up and moving and breaking up sitting time is important for vascular function. But it's also true in children. So this is something else we need to think about in terms of the impact of COVID-19, that repeated daily exposures to uninterrupted sitting and low amounts of certainly vigorous physical activity is unlikely to be a good thing. Okay, now we mentioned snacks and eating foods. So how does that, how can we incorporate that into the discussion about health? So again, this is more data that we collected ourselves in the Children's Health and Exercise Research Centre. So we have some teenagers that came into our laboratory, and we measured blood vessel function using flow-mediated dilation, that ultrasound technique. And they either did no exercise, some high-intensity interval exercise, or some moderate-intensity exercise. And then afterwards, we measured them again for blood vessel function, and then we gave them a high-fat meal. Okay, so we asked our participants to consume a high-fat meal, and 3 hours later, when fat in their blood should be peaking, and they should be at the most amount of endothelial dysfunction, we measured them again. And this is what we found. Okay, so remember, the higher the number on our y-axis, the better. So this is the control trial data. So before exercise, they came in. After exercise, well, this is the control trial, so they didn't do any exercise in the red. And then they had, so let's say the same, then they had the high-fat meal, and blood vessel function came down. So in terms of quarantine, if someone is sitting down all day and then they have particularly unhealthy food intake, they are impairing their blood vessel function. Okay. Now, if they're sitting down all day, this time point would also be lower anyway, but this was just an hour rather than 3 hours. On a separate day, we did some moderate intensity exercise. So this is the orange triangles. So before and after moderate intensity exercise, there was no improvement. However, they were completely protected from the high-fat meal. But just doing some activity, moderate intensity activity, might be favorable because it protects you from the fall in blood vessel function when you're eating a high-fat meal. And then on our final day, our green triangles here, form some high-intensity interval exercise. Again, we see that beneficial effect of blood vessel function, and that was preserved in the postprandial period. Okay. So exercise might be important. Now, how we achieve that under lockdown conditions will be difficult. And this is the last study I'm going to show to you now because my 45 minutes are almost up. This is something that Jodie Cook has researched as part of her MSc with us at Church, and the manuscripts we're looking to submit shortly. We're very excited about. It was looking at what happens when you consume a sugary drink in a child. Now, there's a lot of there's a lot of work in the literature, certainly with adults, where People are given oral glucose tolerance tests, and they've given glucose as a sugar. But the reality is that glucose doesn't necessarily reflect the type of dietary sugar that's consumed in a sugary drink. So that's more sucrose. And sucrose is half glucose and half fructose. And those two different types of sugars are metabolized very differently. So a lot of work has looked at just the effect of glucose, but that doesn't really tell us much about what the effect of a sugary drink actually might do to either an adult or certainly a child. So what we did in this study is that we measured blood vessel function, and then we asked our participants, our teenagers, to consume either glucose, fructose, sucrose, or water. And in the sugary trials, these three trials, they're all matched for the total amount of sugar. So it was 60 grams of glucose, 60 grams of fructose, or 60 grams of sucrose. We then measured blood vessel function again, and I'm not going to talk about them today. We measured lots of things in the bloodstream as well. So our questions there are, what is the acute vascular effect of a sugary drink? Or sorry, what is the acute effect of a sugary drink on blood vessel function? And does the type of sugar matter? Then we asked our participants to consume a high-fat meal for measuring blood vessel function again. Because what we wanted to know is, does consuming a sugary drink influence the response to a high-fat meal as well? And if so, again, does the type of sugar matter? So I'm only going to present the blood vessel function, the flow-mediated dilation data from this. There's a lot of other data in this work, and we're looking forward to publishing this shortly. But what we can see actually is that the glucose and the sucrose, remember this is 50% glucose, those trials, 1 hour after the drink consumption, improved blood vessel function temporarily. Fructose didn't influence blood vessel function. It came up a little bit, but wasn't statistically significant, and water had no effect. So actually, it turns out that having a sugary drink doesn't seem to be bad for this measure of blood vessel function. I hesitate to say that this means it's okay to drink sugary drinks, because we've measured other things, such as uric acid in the blood, and they're telling us a slightly more worrying story. But at least for the flow-mediated dilation technique, actually, this isn't so much of a concern. Then after the high-fat meal, blood vessel function always came down, which is what we expected with the high-fat meal, but the magnitude of the impairment was not influenced by the different type of sugar consumed. So I guess in summary, this is, I suppose, my summary slide. We've talked about cardiovascular disease, and we talked certainly about the vascular component of that, why that's something that as a researcher I'm interested in, and some of my colleagues and PhD students are interested in at the University of Exeter. We've talked about the pediatric component, but from a COVID-19 quarantine perspective, we know that we're seeing a reduction in physical activity. We know that we're seeing an increase in sedentary time. We're seeing an increase in energy intake, and we're increasing our intake of ostensibly unhealthy foods. We certainly know that these foods drive obesity in adults. So that's what we know. But as a research scientist, I'm really interested in what we don't yet know, and how can we try and tease that out. I'm interested in the research frontier, and hopefully there are a lot of questions that you might have that you might want to join us or work with us or collaborate with us in some way, so we can try and understand that. So, for example, the interaction between physical activity and sedentary time, or the interaction between the types of foods that we're eating and physical activity. Or better yet, what happens when you're eating unhealthy foods and you're being very sedentary, but you break it up with a bit of physical activity? So we can see that there's lots of questions to be had. I mean, physical activity itself, or what type of physical activity, or what type of sugar that we're having, or what type of fat, or the amount of it. Is there a dose response? This is an enormous area of potential for work. And I think, although COVID-19 is just a worldwide disaster in terms of an infectious disease, there is still an area of insight to be gleaned with regards to what are the effects of COVID-19 on cardiometabolic risk in children. Of course, what I haven't talked about is the length of quarantine, or the length of lockdown period, or even after lockdown period. Do people go back to their typical routines that they were enjoying before lockdown happened? We don't know the answer to that. But if we look at what happened with Ebola in places in Africa, that's not always the case. People don't tend to go back to their typical school routines after quarantine has occurred. Okay, so there are lessons to be learned there from other outbreaks of infectious diseases as well. So hopefully that's generated a lot of interest for people and some thought. Please do email me directly if you've got some questions after this, or if you'd like to know about the postgraduate opportunities available to you, both for our taught programs and our research programs. And again, I point out that we update our funding webpage regularly, but do drop me an email. It's obviously part of my job to help you out if you are interested in studying at Exeter.